The formula of sum of all positive divisors is denoted by S of n. So if you check the textbook answer, it will be sometimes wrong. So please see the procedure what we have done. If the procedure is right, then the answer will also be a right answer. Be careful. You have to remember this formula to solve the problems to find out sum of all positive divisors. Hello dear students, a warm welcome to one and all. My name is Vibha, Mathematics Faculty, Vidhyaashram Pre-University College, the Temple of Excellence, Mysuru. So in the last session, we have learned how to solve the problem by applying fundamental theorem of arithmetic, and also we have solved the types of problems, the positive divisors of n, by applying the formula of T of n. So in this session, we are going to learn the topics of problems on sum of all positive divisors of n, and then we are going to solve the problems on canonical representation. Now let us move on to how to solve the problem of sum of all positive divisors. Before solving, I am going to give you the formula how to solve the problem here. So here the formula of sum of all positive divisors is denoted by S of n, and it is given by the formula P1 to the power of alpha 1 plus 1 minus 1 divided by P1 minus 1 into P2 to the power of alpha 2 plus 1 minus 1 divided by P2 minus 1 into etc. up to it will go n number of terms, that is Pn to the power of alpha n plus 1 minus 1 divided by Pn minus 1. Be careful, you have to remember this formula to solve the problems to find out sum of all positive divisors. Now let us move on to solving the problems of this formula based. So here we are having the problem, find the sum of all positive divisors of the following number, which is nothing but 6498. So now let us find out by prime factorization method, and then we are going to apply the formula. So 6498 can be written as 6498 can be have the prime factors. Now you know dear students, the number ending with even number can be divisible by only the even prime number, which is nothing but 2. So now let us try to divide by 2 here. So 2 3s are 6, 2 2s are 4, 2 4s are 8, 1 is getting carry over. You are going to have 18. 18 is nothing but 2 9s are, isn't it? Now dear students, the number is ending with what? 9. 9 is cannot be a even number, it is an odd number. So let us try with the odd prime, which is the 3. So therefore 3 1s are, again 2 cannot be divided by 3. So we are going to taking carry over. Here it will become 24, isn't it? So here if you take it as 24, 24 is nothing but 8. So 0 you are going to add it as here, because if you take it directly 8 it will come. So 183 into 3 you have to multiply that. So here 0 is a carry over, 24 is nothing but 3 8s are 24 and 3 3s are 9. So you can multiply dear students and check out. 3 3s are 9, 3 8s are 24, 4 is carrying over, 3 0s are 0, 0 plus 2 is 2, 3 1s are 3, which will gives you back 3 2 4 9. Got? So next we'll be moving on to, again the number is ending with 3, so I can divide it by 3 only. So you are going to have 1 cannot be divided by 3. So I am going to add it to what is that taking carry over, which is nothing but 10. Correct? So 10 is nothing but 3 3s are 9. Again 1 will be getting carry over, which will become 18. So 3 6 are 18 you are going to have. So next it will be 3 1s are 3. So please dear students, check it out here whether 361 is divided by 3 or 361 into 3 is 1083. Let me check out. 361 into 3. 3 1s are 3. 3 6 are, which is nothing but 18. Again 1. 3 3s are 9. 10, correct? 1083, you are going to get back the same answer. Again, the number is ending with 1. So let me check out here. So see dear students, if you check out here, the number ending with 1, if you do it by 3, 3 ones are 3, 3 twos are 6, again 1 is remaining. So it cannot be divisible. You can check it out here. So this cannot be divided by 3 also, 5 also, 7 also, those are all prime factors. It can be only divisible by 19, which is a prime number. So 19s are, which will be a 361. Again 19 is a prime number which is divisible by only 19. 19 ones are 19. So what are all the prime factors you can write for? 6, 4, 9, 8. Let me write it here. 6, 4, 6, 4, 9, 8 will be is equals to, see dear students, see you can observe that 2 is only once, 3 is twice and 19 is twice. So therefore I am going to write it as 2 power 1 into 3 power 2 into 19 power 2. So dear students, you can observe here, which is in the form of P1 to the power of alpha 1 into P2 to the power of alpha 2 into P3 to the power of alpha 3. Correct? So I am going to write it, which is alpha 1, alpha 2 and alpha 3. So alpha 1 is nothing but 1. Similarly, alpha 2 is nothing but 2. This one, powers. And then alpha 3, which is nothing but again 2. So P1, you can compare. P1 is 2. Again, P2 is 3. P2 is 3. Correct? So again you are going to have P3 is 19. P3 is equals to 19. So dear students, you need to observe what is the formula for sum of all. This is a formula to find out the sum of all. That formula I am going to write until where? Until P3, because you are having only till P3 here. So let me write down that formula. So S of n will be is equals to P1 to the power of alpha 1 plus 1 minus 1 divided by P1 minus 1 into P2 to the power of alpha 2 plus 2 minus 1 divided by P2 minus 1 into, you are going to have it as P3 to the power of alpha 3 plus 1 minus 1 divided by P3 minus 1. Observe these students, you are going to have the alpha 1, alpha 2, alpha 3 is 1, 2, 2 and P1, P2, P3 is 2, 3, 19. Let me substitute here. P1 is nothing but 2. 2 to the power of alpha 1 is 1. 2 to the power of 1 plus 1 minus 1 divided by 2 minus 1 into, again P2 is nothing but, you are going to have it as 3. And alpha 2 is 2. So you are going to write it as 3 power 2 plus 1 minus 1 divided by 3 minus 1 into, what is you are having? P3 19 and alpha 3 is 2. So therefore you are going to have 19 to the power of 2 plus 1 minus 1 divided by 19 minus 1. Correct? So here you are going to 2 to power 2 is nothing but 4 minus 1 divided by 2 minus 1 is 1 into 3 power 2 plus 1, which is 3 power 3. 3 power 3 is 27 minus 1 divided by 3 minus 1 is 2 into, again 19 to the power of 3 is 6, 8, 5, 9 minus 1 divided by 18. Correct? So therefore you are going to have, the answer will be is equals to 4 minus 1 is 3 divided by 1 is 3 into 27 minus 1, which is nothing but 26. 26 by 2 into 6859 minus 1 is 6858 divided by 19 minus 1 is 18. So which will be is equals to, which is 3 into 26 by 2 is 13. 6858 divided by 18 is nothing but 381. So 3 into 13 into 381, you are going to get the answer as 14,859. Are you getting? So this is your S of n. Got? So the answer will be C, 3 into 26 by 2 into 6858 divided by 18, and then the answer after multiplication, this 14,859 is your S of n. I hope you understood this problem. We'll be moving on to the next problem. Find the sum of positive divisors of the following, which is 39744. So let me see this, how this 39744 will go by division. So since the number is ending with 4, you are going to have the prime number, which is only 2. You are having even prime number especially. So 2 ones are, you are going to have 2 ones are 2, and then 1 is getting carry over. So 19 it will be, you are going to have 2 8s are 16, 2 9s are 18. Correct na? So 2 9s are 18. Again 1 is getting carry over. So then you are going to have 16, which is 2 8s are 16. Again 1 is getting carry over. Correct? Again 4. You are going to have 14. 14 is 2 7s are 14. Again 2 2s are 4. Correct? Next, again the number is ending with 2, which is divisible by again 2 prime number. So 1 cannot be divisible by 2. So getting carry 19. 19 means you are going to have 2 9s are 18. Again 1 is getting carry over, 2 9s are 18. Again 7. 7 means you are going to have 2 3s are 6. 1 is getting carry over, 2 6s are 12. So again number ending with 6, which is an even number, even prime number, it can be divisible. So 2 4s are 8, 1 is getting carry over. Again 2 9s are 18, 1 is getting carry over. 13 it will become, 13 means 2 6s are 12. Again 1 is getting carry over. 16, 16 means you are going to have 8, 2 8s are 16. Correct? Again number is ending with 8, which can be divisible by 2. So 2 2s are 4, 2 4s are 8, 1 is getting carry over. 16, 16, 2 8s are 16. Again 4 means 8 means 2 4s are 8. Again number is ending with 4, which is even. So 2 1s are 2, 2 2s are 4, 2 4s are 8, 2 2s are 4. Again 2. So you are going to have 1 cannot be divisible by 2. So you are going to take carry over, which will become 12. 12 will be multiplied by 6, it will become 12. 2 6 are 12. Again 2 2s are 4, 2 1s are 2. Correct? You are going to have. So please check off by multiplying. 2 1s are 2, 2 2s are 4, 2 6 are 12. You are going to write it as. Again here the number is ending with 1. So if it is ending with 1, it cannot be divisible by 2. It can be divisible by only 3. So you are going to have, check out here, it is divisible by 3. So 3 2s are 6. 3 2s are 6. Again 2 cannot be divisible by 3. So you are going to take carry over, which will become 21. Correct? If it has become 21, you are going to write it as here 7s are is 27. 3s are 621. Check out that. So it will be carry over 0. 3 7s are 21 into 3. Now 3 7s are 21. 2. 3 2s are 6. 6 plus 2, it will become 8. So which is wrong. So 1 is carry over. That is 0. You can write it as carry over. So it will become 2. 3 7s are 21. Again 207. So 207, again it is a odd number. So can we try with the 3? So it will become what? 3. Yes. So it will be 3 6 are 18. 3 6 are 18. 2 is getting carry over, which will become 27. 27, which will be divided by 9 3s are 27. Correct? 9 3s are 27. But check out here, 69 into 3 is 207. Yes, obviously. So again number is ending with 3. So which will be again 3, and the number is ending with 9, which will be divisible by 3. 3 2s are 6. 3 3s are 9. Correct? You are going to have. Now again you are going to have it as, let me check out, 69 into 3. Which one? This one. If you are having confused. Now here 3 9s are 27. 2. Again 3 6 are 18. 18 plus 2 is 20. You can have 207. Again you are having 23. So 23 is again a prime number, which is divisible by only 23. Correct? 23 ones are 23, which is a prime factors. Now let us write down how many times the prime factors are repeated. So 3974. 3974 can be written as how many times? 1, 2, 3, 4, 5, 6. Correct? So you are going to have 2 power 6 into 1, 2, 3. So 3 power 3 into 23 whole to the power of only one time it is repeated. Now which is nothing but it is in the form of P1 to the power of alpha 1 into P2 to the power of alpha 2, P3 to the power of alpha 3. Now let me write down here what is the P1, P2, P3. What is that? Alpha 1 is nothing but 6 and P1 is nothing but 2. Similarly, alpha 2 is 3 and P2 is 3 and alpha 3 is 1 and P3 is nothing but 23. So let me write down the formula. What is the formula you are going to have? S of n will be is equals to P1 to the power of alpha 1 plus 1 minus 1 divided by P1 minus 1 into P2 to the power of alpha 2 plus 1 minus 1 divided by P2 minus 1 into P3 to the power of alpha 3 plus 1 minus 1 divided by P3 minus 1. So here you are going to substitute accordingly. So what is the substitution you are going to have? So P1 to the power of alpha 1 plus 1, that is 2 to the power of S of n will be is equals to 2 to the power of 6 plus 1 minus 1 divided by 2 minus 1 into again P2 to the power of, that is 3 to the power of 3 plus 1 minus 1 divided by 3 minus 1, isn't it? Into, again you are going to have it as P3, that is 23 to the power of 1 plus 1 minus 1 divided by 23 minus 1. So let me solve this one. 2 to the power of 6 plus 1 is 2 power 7 minus 1. 2 minus 1 is 1 into 3 power 4 minus 1 divided by 2 into 23 to the power of 2 minus 1 divided by 23 minus 1 is 22, which will be is equals to. So now we are going to have 2 to the power of 7 is 128 minus 1 divided by 1 is 1 into 81 minus 1 divided by 2 into, so 23 whole squared is nothing but 5, 29 minus 1 divided by 22. Now which will be is equals to 127 into 81 minus 1 is 80 divided by 2 into 529 minus 1 is 528 divided by 22, correct? Which will be is equals to, so you are going to have it as 127 into 80 by 2 is 40, you are going to have into 528 by 22 is 22, 2s are 22, 4s are, you are going to have, so 24, you are going to have it as, the answer will be is equal to 1,11,920. This is your answer for this question. Okay, next we'll be moving on to the problem. Find the sum of positive divisors of the following number, which is 1026. Let me find out the factorizations. 1026, since 6 is even number, which is only the even prime number, 2 can be divisible by 2, so 1 cannot be divided by 2, carrying over, so it will become 10. So 2 5s are 10, again 2 1s are 2, 2 3s are 6, right? Again 3 is odd number, which is odd number start from 3, which is a prime number. Let me try. 3 1s are 3, the carrying over will be is equals to 2, so 3 7s are 21, again 3 1s are 3, correct? Again if you do it, 3 1s are again, 1 is a odd number, so let me check out with the 3. So 3, 1 cannot be divisible, which will be carrying over, which will become 17. So you are going to have 3 5s are 15, 3 6 are 18 will become more than that. So 3 5s are 15, again 2 will be carrying over, 3 7s are 21, correct? So next you are going to have it as again 3, 7 is an odd number, so 3 1s are 3, 2 is getting carry over, which will become 27. 3 9s are 27. Again, 19 is a prime number which can be divisible by only 1. So what will be the prime factors? So 1, 0, 2, 6 can be written as, which will be is equals to 2 1 time, 2 power 1 into 3, 1, 2, 3 times 3 power 3 into 19 to the power of only 1 time, correct? So therefore you are going to have which in the form of P1 to the power of alpha 1 into P2 to the power of alpha 2 into P3 to the power of alpha 3. Let me write it here, the values. P1 which is 2, alpha 1 is 1, P2 which is 3, alpha 2 which is 3, P3 which is 19 and alpha 3 which is 1. What is the formula? S of n will be is equals to P1 to the power of alpha 1 plus 1 minus 1 divided by P1 minus 1 into P2 to the power of alpha 2 plus 1 minus 1 divided by P2 minus 1 into P3 to the power of alpha 3 plus 1 minus 1 divided by P3 minus 1. So let me substitute accordingly. So that is S of n will be is equals to P1 is nothing but 2 to the power of 1 plus 1 minus 1 divided by 2 minus 1 into, so again P2 is nothing but 3. So 3 to the power of alpha 2 is 3 plus 1 minus 1 divided by 3 minus 1 into, again P3 is nothing but 19. So 19 to the power of 1 plus 1, alpha 3 is 19 minus 1 divided by 19 minus 1, isn't it? So next will be solving this. 2 to the power of 2 minus 1 divided by 2 minus 1 is 1 into t to the power of 4 minus 1 divided by 2 into 19 to the power of 2 minus 1 divided by 18. Right, which will be is equals to 4 minus 1 divided by 1 is 1 only into 3 to the power of 4 is 81 minus 1 divided by 2 into 19 squared is nothing but 361 minus 1 divided by 18, which will be is equals to 4 minus 1 is 3 into 81 minus 1 is 80 divided by 2 into 360 divided by 18. So you are going to have the answer will be 3 into 2 4s are 8, 40 into 18 2s are 36, which is 20. So the answer will be is equals to 2400. This is your S of n. So please dear students, if you check the textbook answer, it will be sometimes wrong. So please see the procedure what we have done. If the procedure is right, then the answer will also be a right answer. So we'll be moving on to the next type of problem. See, give the canonical representation of the following. How to give the canonical representation? Starting, I have told you in the fundamental theorem of arithmetic. If you cannot remember, I am going to tell again. You are going to find out 96 prime factorization. What are the prime factors? 96, since you are going to have even number is ending with 6. So your prime number you are going to divide 2. 2 4s are 8. 1 is getting carry over. So you are going to have it as 2. What is that? 8s are 16. Again ending with 8. 2 2s are 4. 2 4s are 8. Again ending with 4, which is even. 2 1s are 2. 2 2s are 4. Again 2 6 are 12. 2 3s are 6. So again 3 is a prime number which can be divisible by only 1 or multiplied by 1 gives you 3. So what is a canonical representation? Canonical representation of 96 can be written as 1, 2, 3, 4, 5. So which is 2 to the power of 5 into 3 to the power of 1. So this is a canonical representation of 96. Is that so easy? This canonical representation will be asked for 1 marker. Got? Next we'll be moving on to the type of problem which is 156. Let us find out 156 prime factorization method. So the number is ending with 6, which can be divisible by even prime 2. So 1 cannot be divisible by 2, it is getting carry over, correct? So therefore you are going to have it as 2 8s are, it will become more 16, 2 7s are 14, again it is carrying over, again 2 8s are 16, ending with 8, even prime is 2 only, which is divisible by 2 3s are 6, 1 is getting carry over, again 2 9s are 18, again number ending with 9, which is an odd number, so starting from 3 only it is divisible by 3 1s are 3, 3 3s are 9, again 13 is a prime number, only it is divisible by 1. So what is a canonical representation you can have? 156 will be is equal to 2 times 2 to the power of 2 into 3 only one time, 3 power 1, and 13 only one time, 13 power 1. So this is a canonical representation of 156. Is that so easy you are going to have? Next, give the canonical representation of 306. Let me find out here. By prime factorization, number is ending with 6, even prime number is 2. So 2 1s are 2, 1 is getting carry over, 10 it will become 2 5s are 10, again 2 3s are 6. Again 3 is an odd number which can be divisible by only 3. Now you can have 1 cannot be divisible by 3, so it is carrying over, which will become 15. 3 5s are 15, 3 1s are 3. Again you are going to have odd number ending, so 3 is only the odd prime, it can divisible by 3, so 3 1s are 3, 2 is getting carry over, which will become 21, so 3 7s are 21. Now again 17 is what? It is a prime number, so 17 1s are 17. So 306 can be represented as 2 only one time, into 3 2 times, into 17 only one time. So this is your canonical representation. Understood? So we'll see the next problem. Next problem we are going to have, give the canonical representation of 5005. So dear students, listen, let me find out what are all the factors of 5005. You know already 5005 means the number ending with 5, only it can be divisible by 5. Let me divide throughout by 5. So 5 1s are 5, correct? Again 5 zeros are 0, 5 zeros are 0, 5 1s are 5. Again you are going to have it as here 1, if it is ending with either it can be divisible by 3 or it can be divisible by any other number which is a prime factor, correct? If I take it as 5 here, 5 2s are 10, again 0 1 it cannot be divisible by 5. Let me try with 3. So 3 means what? You are going to have 3 3s are 9, again 0 1 it will be 3 3s are 9, 10 it will be, again 3 3s are 9, it will come 11, correct? So 11 means which cannot be divisible by 11. So you can try it with what? It cannot be divisible by 3 also, it cannot be divisible by 5 also. Next prime face nothing but 7. 7 you can try it out. So you are going to have 1 cannot be divisible by 7, you are going to take carry over, so which will become 10, 7 1s are 7, again 3 will be getting carry over, which will become 30, 7 4s are 28, you are going to have, again 2 will be getting carry over, 2 means 21, so 7 3s are 21, correct? So next you can try with what? If you try with 3, so 3 it will be 3 3s are 9, 3 4s are 12, again 23, it cannot be divisible. 7 if you choose, 7 2s are 14, again 3 it cannot be divisible. So 9 it is not a prime, so it will move on to 11. Let me try with 11. So 11 1s are 11, 11 2s are 22, so 11 1s are 11 means 13, so it can be divisible. 11 1s are 11, again 3 is carrying over, 3 33, 11 3s are 33, again 13 is a prime factor which can be divisible by only 1, correct? So you are going to have 5005 of canonical representation will be 5 only one time, into 7 only one time, into 11 only one time, into 13 only one time. This is your canonical representation of 5005. I hope you understood this session. In the next session, we'll be moving on to finding of how LCM and HCF. So next section, we will be playing with LCM and HCF of the given numbers. So thank you, dear students.